everyone, how's it going? Welcome to this part 5 of the self-driving course that we are trying to build. And in this section, we're going to look into what is perspective transform and why do we need it. Let me pause this video a little bit and try to notice the lanes in front of the vehicle right here. They look like they are going to be converging at some point right here. So both of these lanes, it looks like they are going to be merging and converging at some point down the lane. Even though these lanes are parallel, they look like they are converging at some point. So it looks like a triangle, and the car is eventually going to be merging at that point with these lanes. So that's not how it actually looks like. The reason this happens is because of the way our eyes, the way our camera is focused. And basically what happens is these are all pinhole cameras. So there's only one point where everything, all the light converges. So the way it works is at this particular region, the focal length or the area or the distance that it's capturing, it increases as the distance increases. So at this point, it's trying to capture more information compared to this particular region near the camera. So because of that, the lane which was supposed to be parallel, they start to converge at this point because around this region, it's able to capture more information about the surrounding than it was able to do it before. Hence, for that reason, it looks like those roads are converging even though they are parallel. Now, this causes a problem while we are doing self-driving detection, especially to detect the lanes and also the amount of information that's available in this video. So you can see all of these trees, the sky, the other vehicles on the road. These are not, at this moment, we don't need in order for our lane detection. These are nothing but noise in some or the other way. So you want to remove that, you want to focus just on the lanes, and you want to make sure that the camera look at the lanes as though it is a parallel section, not a converging section, because we are going to be using this information about the curvature of the lanes to see whether or not the lane is turning left or right, or is it still just going straight. So for that purpose, it's important for us to make sure that we understand these lanes as parallel. And for that purpose, we're going to change this image and make it look like a perspective transform. So let's see how we can do this. We're just interested in focusing on this point, this particular point, and then this particular point. So this region, which is the trapezoid, which you see right here, that is all what we are interested in. And everything else is noise, and that's what we're going to be focusing on currently. So let's go back to our Colab notebook that we've been building. Previously, in the previous section, we looked into how to remove or calibrate the camera, how to undistort an image because of the distortion that happens within the camera. But now let's look into how we can fix this information about perspective transform. So for this purpose, we're going to be using an image from the repository that we've been working with. Let me open up the image right here for you and bring it here. So this is the image, and this is from the same repository that we have been working with. I'll put the link in the description for you to use. You're basically using this image, and this is a roadway, which is where it looks like the road is supposed to be a straight road, and it's converging. And our point is to just to take out this particular region right here in the image, and then focus on what's that parallel region. So let's come back to our Colab notebook and let's try to download this image. I'm going to just copy this here and come back here, and we will use wget to download the image, and we will call this image as maybe road.jpg. We'll start it off with the function. We'll say 0 -0 -o, and we'll say road.jpg and copy paste the link that we got it from this particular link. And this whole section will be in the description for you to download. We are using runtime factory reset because we don't want any of those previous files from this Colab. We're running it as a new notebook, and you can see here that it's still connecting and we don't have any data available here. So if I press this play button, it will download the image for us, and it should be available for us to use right here. So if I refresh this, you can see there's a road.jpg file now downloaded in our Colab to use. So now what we need to do is, in this particular image, we are interested in to focus just on the trapezoid, which is this region, this region, this region, and then this region. So we're going to let OpenCV know that out of the whole image, of all the pixels that you see in this image, we are only interested in this particular trapezoid. That is where the lane is located. Everything else is noise, so let's get rid of that. So come down here, let's open up a new code block, and we'll start to import our libraries. Import CV2, import numpy as NP, and now we will let OpenCV know that these are the trapezoid points, or these are the points that we are located in. So we'll give the location of this point and this point and this point and this particular point. So let's start by doing that. Now this is an image. The resolution of this image is 120 by 720. So it's 120 pixels horizontally and 720 pixels vertically. So this particular height right here is 720, and this particular width right here is 120. So that's how the image, or the Cartesian coordinates of the image, are reflected. So come down here, let's start giving the points. Now we need to identify where all these points are located. This is something which we'll have to do manually, but in this particular image we already know. But let's come back here and now create the points for ourselves. So the source the source points are np.float 32. So it's going to be a floating 32 point. And now we are just going to initialize all the points where we are located. So this is an array, and now we'll start off with this particular point right here, the top left point, and we'll say this is going to be somewhere in the middle, which is 550, and somewhere in the middle height wise, so 720 by 2, we'll do 460. And the next point is going to be, after this, we'll say this is going to be a tuple, so we'll call it as a tuple. So one coordinate is defined. Now the next coordinate is going to be this particular point here, and we can come down till here, so it's easy for us to use the Cartesian coordinate. So this is somewhere in the first quarter of the horizontal axis and the bottom region of the y-axis, which is the vertical. So we can say this is, the height is 720 and this is approximately 150. So we say 150 by 720. So that's our next point. Again, it's supposed to be a tuple, and we put it under the brackets, and this tuple is nothing but the x and y coordinate for that particular point. The next point will come down here, and we'll say it's going to be this particular point. Again, we'll use this particular edge. So 720 is the vertical and 120 is somewhere where it is here. So just 80 pixels before that, or you could use 120, doesn't matter. 1200, and we say 720, and again a tuple. Let's put it back here in the brackets and comma, bring it down, and the last coordinate initialize the tuple, and the last coordinate is this particular point here, which is approximately close to 75% of the image. We can put it down as 780, 770, and then 460 like we did earlier. 460 for the vertical. So we have 770 by 460. This is something which we'll have to do manually to understand where these what is the region of interest for our purpose. But once we have it, we just initialize all these coordinates for ourselves. Now this is the source, and once we have this source point, we are now going to let OpenCV know that our source location or the perspective is present in this particular region, and please create that perspective region for us. For that purpose, OpenCV has a function called getPerspectiveTransform. So CV2 get perspective transform, and this perspective transform is supposed to take the information from our source and then convert it into a destination file. So this is our source file, and we are going to convert the source, and we'll say stretch this particular region so that our image looks like a top down view. So what we are trying to do here is, if you go back to this video, if you try to play this, you're looking at the road as though it's coming from a front view. So it looks like you are looking at the road from a front view angle. But in lane detection, it's better to have a top-down view so that you can look at the lane as though it's parallel. So for that purpose, you want to make this particular perspective of your camera look from a top-down angle, as though the camera is located somewhere up here and you're looking at the road from the top, like as though it was a satellite which is trying to focus on the image or on the road for us. So instead of looking at the camera from this region, we're going to make this camera look from this particular region. So this whole trapezoid that we just took out, we're going to stretch that to the whole image, and it'll look like as though the road is being looked up from a top-down angle instead of the front view angle. It'll make sense as soon as we make this video. Let's come back here. Let's go back to the Colab file, and here we will now stretch these points, these trapezoid points, to a whole image so that it looks like it's as though being focused just on the road and nothing else. The way we can do that is by creating another destination coordinates, and in that destination coordinates we'll say these are the points and these are the points how you want to be stretching it to. So we say destination points np float 32, and this we call it into an array. The first tuple is going to be, now we're starting to stretch this. So this particular point which was here, now we're going to bring it down and pull it up here. So from here it's going to go to this particular top left corner. So now you want to initialize this particular trapezoid in this region. Similarly, this trapezoid is going to go into this particular top right corner of the image. And the way we can do that is by just saying 100 0. So the image is going to go to top left corner, and once we have this, then we say bottom left corner, and you're going to stretch the bottom image, which is already fine. The bottom image is already towards the corner, so it's not going to be stretching too much. Similarly, this particular bottom image is not going to be stretched too much, but these two points are going to be stretched in the opposite directions. So that's how you're going to make a curving road converging road more parallel. Now, once we have this, we open up another bracket. We say 1100720. In another way, we say we need to put a comma there. We say 1100 and 0. So these are nothing but the source and destination. So you're stretching the image points to their maximum ends. Once we have the get perspective transform, then we create M, which is letting the OpenCV know that we are trying to stretch, or we are just trying to focus on that trapezoid that we are interested in. So we say SRC to destination. So convert our source into destination. And once we convert it into the destination, at some point we also want to go back to our original view, which was the front view. And for that purpose, we'll say M inverse equal to CV2 get perspective transform destination source. Okay, so at this stage, we are just letting OpenCV know that these are the coordinates of the trapezoid that we are interested in, and this looks like they are as though they are converging into some point, and I don't like that. I want to make sure that we are able to convert that into a parallel looking road so that the camera is focused on a top-down angle. And for that purpose, we're just stretching the converging points to the top, to the most extremes of the image. Come back to the Colab file, and once we initialize all of these, now let's call a function. Let's make a new function which can convert our front view to top view. So we'll say define or def function, and we say front to top. So front view to top view, and it can take an image, and once it takes an image, then it will return the whatever the image is into that particular perspective of a top view. Let's initialize the size of the image. In this particular section, we know that the image size is 120 by 720. And once we know all of this information, it can then convert that image. So we do that by returning the warp perspective. So CV2 warp perspective. OpenCV has this function which it can take an image and whatever format you want, whatever perspective you want, it can convert that and give it back to us. We say img m and the size that we initialized, and it needs the type of perspective transform you're trying to do. In our case, we're going to do a linear perspective transform. Right now, we don't need to worry about what are the different types of perspective transforms. It's just one type of perspective transform that we are focusing on. And we say flags is equal to CV2 dot interlinear. This is just one type of perspective transform. So if we were to look into this image, let's try to read this image first. We have image equal to CV2 im read. So let's read this image that we have here, road.jpg. We say CV2 road.jpg, and output is equal to front to top image, and let's display this image for our purpose. Google has this function called CV2 underscore im show, which will use from google.patches or collab.patches import CV2 underscore im show. The CV2 underscore im show image, which is the original image, and CV2 underscore im show output. So let's do that and see what kind of an output do we get. So this is the original image, and this is the perspective transform. So it looks like it's a parallel image. Let me see if I can bring all of them in one frame so it's easy for us to see, or maybe we can even reduce the maximization so we can see the image more clearly. So you can see now this image, now it's able to just focus on those points that we are interested in. So it has stretched the top region of the image, and it looks like almost it's parallel as it should have been. Now we can bring it back to 175 so it's easy for us to type. And here we can also use NumPy HStack to bring both of them in one region. HStack image output, and copy this. Here display is equal to, and now NumPy HStack horizontal stack, so it can bring both the images in one section. And we will do CV2 underscore im show display. So let's do that, and we can now see both of them adjacent to each other, and we can see how this image has been perspectively transformed into this top view approach. So it looks like in this particular section, it looks like the image is being viewed from a top angle. Now, what if we want to bring it back to this particular format, minus all of this region? So let's do that, and come back here. We'll define another function in this region. We'll say def top to front, take the image. Again, we'll define the size of this image as 1280 by 720, and we will now return CV2 warp perspective the opposite way. We'll say img, and instead of using m, we'll say m inverse. So m inv, use the size that we know, and the same flag is equal to CV2 linear interlinear. This is just one form of flag that we are using, and it returns the perspective in the opposite direction. So it's the same code, we're just converting, instead of m we are using m inverse. That's about it. And now here we can say output, instead of calling it output, we'll call it output top, and here we'll call it as output front for front view, and we'll call the function top to front, and we'll send our output top that we just got from the previous option. Once we have this, let's display it for our purpose. We'll call it, or maybe we can bring it down in the same hedge stack, and we say our output front, and since we named this, we changed this name or file name, we say output top. Let's run this and see what kind of an output do we get here. It's displaying, and you can see that we have a new image, which is nothing but just focusing on the road that we are interested in. So it extracted that trapezoid that we were interested in, and it's just given that information, and everything else in the road has been taken out, and eradicated. So this is how you're converting. So what basically happens is you first do our camera calibration, we remove the distortion that like we saw in the previous sections, and once we remove the camera distortion, then we change the image to a perspective transform. So we are only focusing on the lanes and then trying to remove that perspective error that comes into the road because of the field of vision of the camera. Because the camera is a pinhole camera, it looks like the roads are converging. So we remove that converging effect of the perspective transform, and then once we use this image in the next section. This image will go into the next section where we will try to understand where are these lanes moving, or we'll try to draw lines on the road using these lanes, and then try to see where are these lanes going, whether they're going in the left or right direction, and try to understand that. And then lastly, we'll come back to our main section so we can let the driver know that this is how the road looks like, and the camera and the self-driving system is looking at the road in this way, and it's focusing on this particular region, and that's how it's able to know whether the road is going to turn left or right. So that's the agenda for the next sections, and let's see how we can go about it. With that, take care, stay safe, bye-bye.